Diving in today, folks, into something you literally cannot live without.
Uh-huh.
We're talking blood pressure, folks. What is it? How does it work? And why does that number, 120 over 80 matter so much?
Right.
We're using some in-depth medical excerpts today, so let's jump right in.
You know, it's funny. Most people have heard of blood pressure, but they don't actually know what those numbers represent,
Yeah,
really.
it's one of those things you hear all the time. You should understand it, but do you really?
Yeah.
So systolic, diastolic, you hear it at every doctor's appointment, right?
Right.
What is the difference between those two numbers? Why two numbers?
Well, think of it this way. Every time your heart beats, it sends a wave of blood through your arteries. And that peak pressure, when your heart bumps, when it contracts, that's your systolic pressure.
Okay.
And then between beats, when your heart's relaxing, there's still pressure in the system, kind of like a baseline, and that's your diastolic pressure.
So peak and valley
Exactly.
with a heartbeat.
Exactly. It's a ratio. That's why you see 120 over 80. And that's not just a random number. That number is based on decades of research, looking at huge populations and seeing, what blood pressure reading leads to the best outcomes for people.
Interesting. So 120 over 80, that's kind of the ideal based on decades of research.
Exactly. It's the one that, for most adults, seems to minimize cardiovascular risk.
Gotcha. Okay, well, we've got this other term. Arterial pressure, MAP.
Right.
What is that?
MAP is really interesting because it gives us a more holistic view of the pressure in your system.
Okay.
Instead of just looking at the peaks and valleys, MAP is the average pressure throughout your whole cardiac cycle. And it basically tells us how efficiently blood is reaching your organs.
So MAP, is that kind of like the Goldilocks zone for your blood pressure? Not too high, not too low?
Exactly. That's a great way to put it. And calculating MAP is actually pretty simple. You take your diastolic pressure and add 1/3 of what's called the pulse pressure, which is just the difference between your systolic and diastolic.
So, if my blood pressure is 120 over 80, my pulse pressure would be 40. A third of that is about 13. Add that to my diastolic pressure of 80, and I get an MAP of 93.
You got it.
Okay.
And that MAP number tells us how well your organs are being perfused,
Okay.
which just means how well they're receiving the oxygen and the nutrients they need.
Makes sense.
Yeah.
Now, how does blood pressure change as it moves throughout your body?
Yeah.
It's not just constant, right?
Absolutely not. Imagine a wave like traveling down a rope. That's kind of like what happens to your pulse pressure, that difference between systolic and diastolic.
Okay.
It decreases as blood moves away from the heart. It's like a dampening effect. And there's two main reasons for that.
Okay, I'm picturing the wave. Why does it dampen?
Well, first, your arteries aren't like rigid pipes. They're
Right.
very elastic, and that elasticity helps absorb the initial pressure coming from the heart,
Yeah.
like a built-in shock absorber system. Then, as the blood moves through the vessels, there's friction between the blood cells and the walls of the vessel. That friction also leads to a decrease in the pressure.
So it's kind of like the elasticity and then also the friction in the blood itself.
Exactly.
That kind of evens out the pressure.
Right, and this leads us to these amazing little vessels called arterioles.
Okay.
They're like the unsung heroes of blood pressure regulation.
Arterioles.
Yeah.
Tell me more.
Imagine you're approaching a big city, right? And there's these big highways leading in.
Yeah.
But then as you get closer, the highways split off into smaller roads. And then those roads split off into even smaller streets, allowing traffic to kind of flow everywhere in the city.
Okay.
That's what arterioles do for your blood.
So they're like the distributor vessels.
Exactly. They branch out from the arteries and they lead into the capillary beds, which are those tiny, thin-walled vessels where the actual exchange of oxygen and nutrients and waste products takes place.
So they're right before, the delivery point.
Right, exactly.
Interesting.
And here's what makes them so important for regulating blood pressure. Arterioles are surrounded by smooth muscle tissue.
Okay.
And this muscle tissue can constrict or relax, changing the diameter of the arteriole, which controls how much blood flows through.
Okay.
It's like having all these little valves all over your body that are constantly adjusting blood flow to meet the needs of your tissues.
It's amazing how much is happening in those tiny little vessels. So they really are like the gatekeepers
They are.
of blood flow.
And what's really cool is they're affected by so many different things. Nervous system signals, hormones, even the local chemical environment. It's a very dynamic system,
Yeah.
always adapting.
It's wild that, we think of blood pressure as just this one number.
Right.
But it's this complex interplay of all these forces,
Hmm.
you know, the heart pumping, the elasticity of the arteries, these tiny little arterioles,
Yeah.
all working together to keep everything in balance.
It's all happening automatically without you even having to think about it.
That is pretty remarkable.
Yeah.
So today we've gone from systolic and diastolic to understanding MAP to, talking about how blood pressure changes as it goes through your body, met the arterioles.
Right.
It's made me realize blood pressure is a lot more complex than you might think.
It really is. It's a very dynamic, intricate system. As you go about your day, maybe think about how things like exercise or even stress might be affecting those arterial
Right.
and ultimately affecting your blood pressure.
Right, because that connection is not something people often think about.
Yeah, it's a connection that's often overlooked, but very important for our health.
Absolutely.
Yeah.
Well, thanks for listening, everybody.
Thanks for having me.